Okay, this is the P1 paper for January 2021. We're up to question number 6 now. This is the graphs and transformations question. And if we look here, we can see there's reciprocal graphs, and a little bit later on, there's going to be the translation of graphs. So let's have a look and make a start on this. Part A here says, can we sketch the curve with the equation y equals minus k over x, where k is greater than 0 and x isn't equal to 0. Right, so they're relying on us having a certain amount of knowledge here, pre-existing about some of our standard curves. So if I draw out a set of axes, you don't need to do this bit, but this is me explaining it to you. What they're assuming is that you know what 1 over x looks like. Okay, the reciprocal graph. We know what 1 over x looks like. It looks like that, where we'd have an asymptote here and an asymptote there. Don't tend to put those on because of the axes, but they're there. And this is y equals 1 over x. So if we want y equals minus 1 over x, or y equals minus 1 over x, then would just be using the other quadrants. So that's y equals minus 1 over x. And if I've got minus k over x, that's not going to make any real difference to this graph. In effect, it would move slightly further away from the axes there. It's multiplied by k. But in terms of our sketch, there are no substantially different points. So that's going to do for y equals minus k over x. Just quickly to note that because k is a positive, then it is going to look like that, rather than if k was negative, then it might flip back over again. But yep, that's the answer for 6A. 6B then says, once you've done that, can you now do minus k over x plus k? Well, absolutely we can. Part B. Now what I'm going to do, I'm actually going to use my iPad here, but this is only to show you guys the transformation. If that's the same graph, y equals minus k over x, this is y equals minus k over x. If I do plus k now, plus k, that transformation means that the whole graph will move up by k units. So if this whole graph moves up by k units, doesn't matter how big you do it, just shift it up a little bit. So we've moved that up by k units there. The key then for this one is the fact that that asymptote is going to move up by k units, and so is going to be easily recognizable and will form part of my actual written answer here. So as long as I now draw an asymptote going across there, not perfect but good enough, this is y equals k. Let's just move the graph out of the way a little bit. So if we look at the question said, can we, in our sketch, write down the equation of the horizontal asymptote? The other thing that I haven't done yet, it says, can we find out where it hits the x-axis? Yeah, I can do that. That's going to take me a little bit of algebra. So I'll do that just underneath, a bit of space underneath. So if I want for intersect with x-axis, we're just going to have y being equal to 0. So that means minus k over x plus k will be equal to 0. And now I just need to rearrange this. I only want x, so k is equal to k over x. Swap that up, swap that down at the same time. This isn't complicated, I'm not spending any time on this. X works out to be k over k, or works out to be equal to 1. So the intercept is going to be the point 1, 0, but I'm going to go back and clearly label that on my sketch here. So I think I've got everything that I needed to for part B there. That's all done. Part C says, find the range of possible values of x for which the curve with the that equation, y equals minus k over x plus k, when does it not touch or not intersect with the line y equals 3x plus 4. So I'm experienced at doing these. I know exactly what I need to do. So my game plan is going to be, I'm going to do the opposite. I'm going to try and find out where this one does meet or intersect with that, which means just putting them equal to each other. Once I've put them equal to each other, so we've done lots of these, this is going to turn into a quadratic. I'll try and solve the quadratic, but if there's going to be a point where it doesn't intersect, then the quadratic won't solve. Okay, so when I try and solve the quadratic, I'll get b squared minus 4ac, and I'll say that's going to be less than 0, and hence it won't actually solve out. So let's have a go at doing that now. I haven't told the examiner what I'm going to be doing. So here, for part C, I'm going to say y equals 3x plus 4 meets y equals minus k over x plus k, where the two things are equal to each other. So when 3x plus 4 equals minus k over x plus k. So I want to solve this. It's going to turn into a quadratic, but then because they're telling me it doesn't meet, there aren't any points, when I get that quadratic, I'm just going to say b squared minus 4ac is less than 0, and then try and sort out what's going on with that. So let's turn it into a quadratic first. Simplest way to do that, multiply everything by x to get rid of the fraction there. So if I multiply everything by x, I'm going to get 3x squared, I'm going to get 4x, I'm going to get minus k because that one's gone, and I'm going to get plus kx. Okay, I want to make that look like my standard quadratic, which is x squared, x's constants equal 0. So taking everything over to that side, I'm going to get 3x squared plus 4x minus kx plus k equals 0. And what I really want that to do is to look like a, b, and c for my constants. So I'm going to say 3x squared, not changing that, but this thing here, I'm going to call it 4 minus kx plus k equals 0. So remember what we're doing here. The whole point about this is that obviously I can't solve this quadratic. I've got too many variables in it, but I'm not trying to solve it. They told me that there were no points of intersection. It doesn't touch, it doesn't intersect. So my quadratic should not work. So if my quadratic's not going to work, if it's not going to give me two solutions or a set of repeated solutions, then I'm going to say b squared minus 4ac is less than 0. So if I do that now, I'll get something that I should be able to solve. So b squared minus 4ac less than 0 is 4 minus k squared, that's b squared, minus 4ac is 3k here, oops, is less than 0. Right, you take your time to multiply this all out. We don't want to make any mistakes, but for anybody who's watched my videos before, I'm not taking ages over that one. You can do 4 minus k times 4 minus k and take your time to work it all out. I know that's k squared minus 8k plus 16. And then the rest of it is minus 12k there is less than 0. So that's going to give me k squared minus 20k plus 16 is less than 0 here. And now I need to solve this quadratic inequality. The way I solve a quadratic inequality is I'm going to say k squared minus 20k plus 16 is equal to 0 to find the critical values. Okay, I want to know where this quadratic hits the axes. Those are the critical values, and then I'll be able to say this quadratic is less than 0 in between the two critical values, but I've got to find what those critical values are. So that's all I'm doing. Let's actually go ahead and do that then. Well, if I've got this one, I would always try and factorise. It's only because I've done this question before, I know it doesn't factorise, but I would always give it a quick go. But then if it doesn't factorise, just use the quadratic formula on it. So k is going to be equal to minus b, which is 20, plus or minus the square root of b squared minus 4ac is going to be minus 20 squared minus 4 times 1 times 16 all over 2a. So all over 2. That works out to be k is 20 plus or minus the square root of, that's 400 minus 64 all over 2, which gives me, stick into the calculator if you want to, it works out to be 10 plus or minus 2 root 21. And now I do need to finish this a little bit off then with a sketch. Sketch does not need to be anywhere near accurate. It just needs to be very clear as to what we're trying to do here. So I get 10 plus or minus the 2 root 21 means I'm going to have these two values here, 10 plus root 21 and 10 minus root 21. I don't know whether that's actually going to be negative, doesn't make any difference to my answer here. So my quadratic is less than 0 in there. So that means that k is going to be less than 10 plus 2 root 21, but greater than 10 minus 2 root 21. And that's going to be my final answer. Just always, I'm trained myself to go back and just check anything else. Now, it says k is greater than 0. So, yeah, that whole thing is going to be just moved slightly over there. Doesn't make any difference to the actual final answer then. Well, okay, that's how you do that one. Hopefully that makes sense.